Hi, everybody. Let's look at this problem using homogenized barycentric coordinates. Let ABC be a triangle with in-center I and x-centers IA, IB, and IC, opposite A, B, and C, respectively. Let D be an arbitrary point on the circumcircle of ABC that does not lie in any of the lines IA, IB, IC, or BC. Suppose the circumcircles of DIIA and DIBIC intersect at 2 points, D and F. If E is the intersection of lines DF and BC, prove that angle BAD equals angle EAC. So to use barycentric coordinates, we use ABC as the reference triangle. Then it's well known that I has coordinates A, B, C. IA has coordinates -A, B, and C. IB has coordinates A, -B, and C. And IC has coordinates A, B, -C. Now, assume that D has arbitrary coordinates X, Y, Z. Then, we can use the formula for the circumcircle, and we have that points D, I, and IA satisfy A squared y1 z1 plus minus b squared x1 z1 minus c squared x1 y1 plus x1 plus y1 plus z1 times ux1 plus vy1 plus z plus wz1 for arbitrary constants u, v, and w. And so now, to solve for this, we can substitute I, IA, and D into these equations. And solving linearly ends up giving that U equals BC, V equals BC squared X over CY over BZ minus CY. And solving for W gives that W is B squared CX over CY minus BZ. And if we can use this formula again for circle DIBIC, we can find similarly that the coefficients are negative BC, V1 is BC squared X over BZ plus CY, and W1 equals B squared CX over CY plus BZ. And so from here, we note that since these two circles intersect at points D and F, the line DF is simply the common chord of these two circles, which is the same as its radical axis. So using the barycentric radical axis formula, we have that the radical axis formula U minus U1 X 2 plus V minus V1 Y2 plus W minus W1 Z2 equals 0. And so now here we can substitute, and we want the intersection of this in BC, so we want the first coordinate to be 0. Note that the point 0, B squared Z, C squared Y satisfies these equations by substituting U, V, W, U1, V1, W1. And this point has the same angle with BAD and EAC, obviously because of from the formula for the isogonal conjugate, which concludes the problem.